Okay, this is a question number 25 from HC Verma, Fluid Mechanics chapter. So here there is a cube of ice of h 4 centimeter, which is placed in a empty cylindrical glass of inner diameter 6. So the dimensions of the cube and the dimensions of the empty cylindrical glass are somewhat closer actually here. So let us say that the cube is like this, and the container on the other hand, it's a cylindrical container like this. Now what will happen is this ice which is kept here will start to melt, and this ice, once it melts, actually it will melt to form water, and it will melt uniformly on all the sides. And so slowly what will happen is the size will get reduced, and if this size gets reduced, then water is being formed. Now water which is formed, what will happen is, because there are crevices in the ice microscopic level, the water will go actually between the base of the container and the base of the ice. So between this region of the ice base and the container base, water will come, and because the ice is melted, water is there here also in the sides. And the important point here is that the water is there beneath the ice also. Okay, and so what will happen is, the water which is there beneath the ice, it will apply an upward pressure force on the ice like this. And so this will be as good as this part of the ice is actually kind of immersed in water, because left right also water is there and below also water is there. And what will happen is, slowly, because water is rising, so immersed volume is increasing, and a time comes when immersed volume becomes equal to the weight. And when that happens, I mean not immersed volume into density of liquid into G, which is the buoyant force. That buoyant force becomes equal to the weight of the remaining cube, and at that time what will happen is, the tube will go up and start to float. And we have to find the length of the ice cube when this is just going to happen. So let us say, let us just find out when does this happen. Now what we can assume is that the height of the water which is formed is h. Okay. Now let us also assume that the side length is L right now, whereas initially the length was capital L. So capital L is initial length, right now present length at the time of leaving the surface, leaving the bottom of the vessel and going up, at that time the length is small l. So what is the initial volume? L cube. What is the volume right now? Small l cube. So this much volume is gone. This much volume gone into the density is equal to mass gone. Mass of ice gone is equal to mass of water formed. So mass of water formed is density of water into volume of water formed. Okay. Now let's say the water height is h. So what is the volume of water? So in what area volume water is present? So water is present in pi d square by 4 minus L square, because if you consider the diameter to be d, then the base area is pi d square by 4. But out of the total area of cross section of pi d square by 4, L square area is occupied by ice. So only in this much area water is present. So area into the height will give us the volume of water, and this volume of water can be written as rho of ice into L cube minus L cube by density of water. Here I think you can take the density of water and the okay. Now so this is equation number 1. Now what are the unknowns here? Unknowns are small l and small h. These two are unknowns, but this is just the volume conservation we have done so far. What we need to do is also the force balance. Like this is just at the verge of getting lifted up, which means buoyant force equal to mg. So density of ice into volume of ice is the mass of ice into g, and that is equal to the buoyant force. And how much is the volume of the water displaced kind of thing, that is the immersed volume. Immersed volume is this red shaded volume, which is having the area of L square and height of h. So immersed volume into density of water into g is the buoyant force, and these two are same. So from here we get the second equation in L and h, and the first equation in L and h we already have. So two unknowns are L and h, and two equations are equation number 1, which is volume conservation, and not the volume conservation, the mass conservation, like whatever mass of the liquid has been melted, same mass of water has been formed. So that is this mass conservation. And from this mass conservation we are going to get a relation, because we are going to get the volume of water, or we are going to write the volume of water in terms of h. And the second equation is this buoyant force. So two equations, two unknowns, you should be able to get the answer.